In 1942, a desperate British farmer discovered something that changed everything he thought he knew about garden pests. With chemical pesticides rationed for the war effort, he watched helplessly as aphids devoured his cabbage patch, row by row. Then his neighbor suggested something that sounded ridiculous. Plant flowers to attract the bugs, not to kill them, but to lure them somewhere else. Within weeks, his cabbages stood untouched, while nasturtiums at the edge of his garden writhed with aphids that never touched his food. He had stumbled onto a method as old as agriculture itself, one that modern science is only now beginning to explain. For less than $1, you can make your vegetables invisible to the very pests that have plagued gardens for generations. The secret is not in a spray bottle. It is in understanding how insects actually find your food. This is the science behind one forgotten strategy and the homemade spray that could end your war with bugs forever. Every insect that lands on your tomato plant is completing a journey that began miles away. Aphids, whiteflies, and flea beetles do not wander randomly through the garden, hoping to bump into dinner. They navigate with a precision that would put most GPS systems to shame. The secret is chemistry, invisible clouds of scent molecules that rise from every leaf, flower, and stem. Plants broadcast their location constantly, releasing volatile organic compounds that drift on the wind like a dinner bell ringing across the neighborhood. To an aphid's antenna, your garden is not a quiet patch of green. It is a symphony of chemical signals, each plant shouting its identity into the breeze. Scientists at Rothamsted Research in the United Kingdom have spent decades mapping this invisible landscape. Their work reveals that insects possess olfactory receptors so sensitive they can detect a single molecule of a plant scent among millions of air particles. An aphid searching for a host can smell the difference between a cabbage and a Brussels sprout from hundreds of meters away. The antenna does not just detect presence, it measures concentration gradients, following the scent upwind like a bloodhound tracking a fugitive. This is why your vegetables get hit first, while weeds nearby go untouched. The bugs are not random, they are locked onto a chemical target. But here is where the story gets interesting. Not all plant signals say, "Eat me." Some plants have evolved to scream so loudly that they drown out the whispers of your vegetables. Others produce compounds that jam insect radar entirely, scrambling the signals that guide pests to their targets. For thousands of years, farmers understood this instinctively, even if they could not explain the chemistry. They planted certain crops together and watched pests disappear. They brewed concoctions from garlic and hot peppers, not knowing they were weaponizing the very molecules insects use to navigate. The knowledge was passed down through generations, then largely abandoned when synthetic pesticides promised an easier path. Now, with chemical resistance spreading and health concerns mounting, that ancient wisdom is finding its way back into the garden. The science has finally caught up to what our great-grandparents knew all along. The term trap cropping sounds modern, but the practice predates written history. Archaeological evidence from Mesoamerican sites shows that indigenous farmers planted specific crops at field edges more than 2,000 years ago, creating buffer zones that protected their main harvests. In medieval Europe, peasant farmers grew strong-smelling herbs between vegetable rows, not for culinary purposes, but to confuse the pests that threatened their food supply. The logic was simple. If bugs prefer one plant over another, give them what they want somewhere else. The technique survived in farming communities around the world until the 20th century, when synthetic chemicals promised to end the need for such careful planning. The modern rediscovery of trap cropping began in the cotton fields of the American South. In the 1980s, researchers at Texas A&M University were battling the boll weevil, an insect that had devastated cotton production for decades. They noticed that certain weedy plants around field margins attracted weevils away from the cotton itself. Rather than eliminating these weeds, they began planting them strategically, creating sacrificial zones that concentrated pests where they could be managed or ignored. Yields increased. Pesticide costs dropped. The scientific literature started filling with studies confirming what traditional farmers had always known. The principle works because of a quirk in insect behavior called host preference. When given a choice between two suitable food sources, most pests will consistently choose one over the other. Aphids land on nasturtiums before they ever touch a tomato plant. Flea beetles swarm radishes while ignoring nearby kale. The preference is not absolute, but it is strong enough to shift the balance. By planting a highly attractive trap crop at the edge of your garden, you create a magnet that pulls pests away from the vegetables you actually want to eat. The trap crop becomes a decoy, absorbing the first wave of insects and often keeping them occupied for the entire season. Your main crops sit in relative peace, shielded by the very plants that seem to be crawling with bugs. Nasturtiums are the gateway plant of trap cropping. Their bright flowers and round leaves attract aphids, whiteflies, and cabbage moths with an almost magnetic pull. Plant them in a ring around your brassicas or at the corners of raised beds, and watch as pests swarm the nasturtiums while your vegetables remain untouched. The effect is not subtle. Within days of an aphid infestation appearing in the garden, the nasturtium leaves will be coated with the insects. Gardeners who do not understand trap cropping often panic at this sight, reaching for the spray bottle. But the smart grower smiles. Every aphid on that nasturtium is an aphid that is not on the kale. The science behind nasturtium preference comes down to glucosinolates, sulfur-containing compounds that give brassicas their distinctive flavor. Nasturtiums produce these compounds in concentrations far higher than most vegetables. To an aphid, the scent signature is irresistible, a concentrated version of exactly what it is searching for. Research published in the Journal of Chemical Ecology found that aphids exposed to both nasturtiums and cabbage in controlled experiments chose the nasturtiums over 90% of the time. The preference was so strong that even heavily infested nasturtiums continued to attract new arrivals while nearby cabbages remained clean. Beyond nasturtiums, the trap cropping playbook expands into a full arsenal of decoy plants. Radishes planted among squash attract flea beetles away from the main crop. Dill and fennel pull in tomato hornworm moths before they reach your tomato plants. Sunflowers at the garden edge become landing pads for stink bugs. Each pairing exploits a specific host preference, turning the insect's own instincts against it. The key is placement. Trap crops work best when planted at garden edges or between rows, creating a perimeter of sacrifice that pests encounter first. Once they settle on the trap crop, most insects stay put, feeding and reproducing on the decoy while your vegetables grow in peace. But what happens when trap crops are not enough? What if pests breach the perimeter and start munching on your actual harvest? This is where the second secret enters the story. A spray so simple you can make it from kitchen scraps, yet so effective it scrambles insect radar like electronic warfare. Garlic has protected crops for as long as humans have cultivated it. Ancient Roman agricultural texts describe garlic water applied to vines to repel insects. Chinese farmers documented similar practices more than 1,000 years ago. The active compounds include allicin and its breakdown products, sulfur-based molecules that disrupt the chemical sensors insects use to find food. When you spray garlic extract on a tomato plant, you are not creating a toxic barrier. You are masking the plant's natural scent signature, making it harder for pests to locate. To an aphid drifting on the wind, a garlic-treated plant smells like noise instead of signal. Capsaicin intensifies the effect when you add chili peppers to the mix. Capsaicin, the compound that makes peppers hot, triggers pain receptors in mammals and insects alike. More importantly for pest control, capsaicin derivatives create a sensory overload that interferes with the olfactory receptors insects depend on. Studies at the National Autonomous University of Mexico showed that capsaicin exposure temporarily disables the antenna receptors that aphids use to detect host plants. The insects do not die. They simply lose the ability to smell their way to food. A garden sprayed with garlic and chili becomes a sensory desert, a place where pests cannot navigate. The recipe is almost embarrassingly simple. Crush 5 cloves of garlic and 2 hot peppers into 1 quart of water. Let the mixture steep overnight. Strain out the solids and add a few drops of dish soap to help the spray stick to leaves. Total cost depends on your pantry, but it rarely exceeds $1. The soap serves as a surfactant, breaking the surface tension of water, so the garlic and capsaicin compounds coat the leaf surface evenly. Without it, the spray beads up and rolls off, reducing effectiveness by half or more. Application matters as much as ingredients. Spray early in the morning or late in the evening, when beneficial insects like bees and ladybugs are less active. Coat both sides of the leaves, paying special attention to the undersides where aphids and whiteflies congregate. The treatment needs renewal after rain or every week in dry weather, as the volatile compounds evaporate over time. Some gardeners add a tablespoon of vegetable oil to extend the spray's persistence, creating a thin film that holds the active ingredients on the leaf surface longer. The skeptic might ask why this works when industrial pesticides often fail. The answer lies in resistance. Chemical pesticides target specific biological pathways, and insects evolve resistance to those pathways within a few generations. But garlic and capsaicin do not kill through a single mechanism. They create confusion, masking plant signals, and overloading sensory systems. There is no single mutation that allows an aphid to suddenly smell through a cloud of allicin. The disruption is too broad, too fundamental to the way insects navigate their world. In field trials at the University of California, garlic-based sprays showed no decrease in effectiveness over 5 seasons of continuous use, while synthetic alternatives lost potency within 2 years. The combination of trap cropping and garlic chili spray creates a layered defense that mimics natural ecosystems. In wild plant communities, no single species dominates. Strong-smelling plants grow alongside mild ones, creating a patchwork of signals that makes life difficult for any pest trying to specialize. Monoculture. Agriculture strips away this diversity, rolling out a red carpet for insects adapted to specific crops. When you plant nasturtiums at the edge of your vegetable patch and spray your tomatoes with kitchen-made repellent, you are rebuilding complexity. You are making your garden hard to read, a place where pests struggle to find what they are looking for. A retired extension agent keeps a journal tracking pest pressure across his quarter-acre vegetable garden. Before adopting trap cropping, he recorded significant aphid damage to his brassicas every season. Chemical sprays provided temporary relief, but required constant reapplication. The year he ringed his beds with nasturtiums and started weekly garlic sprays, his damage notes dropped to near zero. The aphids were still present in the garden, clustered on the sacrificial flowers at the edges. But his cabbages, his kale, his broccoli grew clean and unblemished. His pesticide budget dropped from over $200 a season to less than $10 a season. The science keeps confirming what practitioners discover in their own plots. A meta-analysis published in Agriculture, Ecosystems and Environment reviewed 43 studies on trap cropping across multiple continents. The average reduction in pest damage exceeded 60%. When combined with companion planting and aromatic sprays, some studies reported protection rates above 90%, matching or exceeding synthetic pesticide performance without the associated risks. The authors noted that trap cropping worked best when integrated into a diverse planting scheme, exactly the kind of complexity that intensive chemical agriculture has spent decades eliminating. Not every garden pest responds equally to these methods. Trap cropping excels against mobile insects that navigate by scent, like aphids, whiteflies, flea beetles, and cabbage moths. It shows less effectiveness against soil-dwelling pests, like root maggots, or highly mobile predators like grasshoppers. Garlic spray deters soft-bodied insects, but offers little protection against beetles with hard shells or caterpillars that spend their lives on a single plant. The wise gardener uses these techniques as part of a broader strategy, not as a silver bullet. Use row covers for root vegetables. Use handpicking for large caterpillars. Use trap crops and sprays for the sap suckers and leaf chewers that do the most damage to tender greens. Today, global pesticide use tops 4 million tons annually, while insect resistance renders more chemicals useless each year. Pollinators decline as collateral damage. The true cost of convenience comes due in dead bees and contaminated watersheds. Meanwhile, a handful of nasturtium seeds costs less than a candy bar, and a head of garlic from the grocery store can protect an entire garden for a month. The question is not whether these methods work. Decades of research and centuries of tradition confirm that they do. The question is why we ever stopped using them in the first place. The industrial answer is scale. You cannot crop a 1,000-acre cornfield. You cannot spray garlic water from a crop duster. The methods that work beautifully in a backyard garden do not translate to commodity agriculture built on uniformity and efficiency. But for the home grower, the market gardener, the smallholder trying to feed a family without poisoning the soil, these techniques offer something chemicals never could. A way to work with nature instead of against it. A system that becomes more effective over time as beneficial insect populations recover. A path to abundance that costs almost nothing and harms almost nothing. The nasturtiums blooming at the edge of your garden are not decoration. They are soldiers standing guard, drawing fire so your vegetables can thrive. The garlic and pepper scraps destined for the compost pile hold the raw materials for an invisible shield, a sensory smokescreen that makes your plants disappear to the very pests that want to devour them. The knowledge is older than any chemical company and simpler than any formula printed on a spray bottle. It survived because it worked. It was forgotten because something easier came along. Now, as the limits of that easier path become clear, the old wisdom waits patiently to be rediscovered. What would change in your garden if you stopped fighting pests and started outsmarting them?